So today we're going over the properties of a trapezoid and the kite, so chapter 7 in section 5. A trapezoid is a quadrilateral with exactly one pair of parallel sides. Each of the parallel sides is called the base. The non-parallel sides are called legs. And the base angles of a trapezoid are two consecutive angles whose common side is a base. So, just so you guys, let's put this into some words. The trapezoid is a quadrilateral, so it has four sides. We know that a trapezoid has one pair of parallel sides, which are the top one right here, the bottom one right there. Those are called bases. The parallel sides are the bases. The other two sides are the legs. And again, in a trapezoid, since it's a quadrilateral, we have what it's known as the base angles, which are these four. They're consecutive, so in this order. Angles that are on the base. If you were to have done them this way, this is also a consecutive angle, but that is not considered base angles because they're sharing the leg, not the base. So it is important that it shares the base. If it shares the base, then it is a pair of base angles. So if the legs of a trapezoid are congruent, the trapezoid is an isosceles trapezoid. So what does that mean? That we have the two parallel sides, and then if they tell you that the two sides are congruent, then it's an isosceles. If you guys remember, for a reference, an isosceles triangle have congruent sides as well that are across from each other. So if you guys remember that an isosceles triangle has two congruent sides, and you get the same word for a trapezoid, that means the two legs are also going to be congruent. Again, these are the legs of a triangle, and these are the legs of a trapezoid. So it's the same thing that's going to be congruent on both shapes. So at least you have some knowledge of it from previous chapter. All right, now we have the isosceles trapezoid base angle theorem. What does that mean? If a trapezoid is an isosceles trapezoid, then each pair of the base angles is congruent. So, you remember the properties of a triangle? The isosceles, those angles will be congruent to each other. It's the same property for this trapezoid. If we have the isosceles trapezoid, then the base angles will be congruent. So, it's the same, it applies the same way. Now, for the next one is the isosceles trapezoid base angle converse, which says if a trapezoid has a pair of congruent base angle, then it is an isosceles trapezoid. So here we go backwards. They tell you the angles are congruent, and because the angles are congruent, we can say the sides of the trapezoid are congruent. Same with for the converse for the isosceles triangle. So it is stated that if angle A is congruent to angle D, if angle B is congruent to angle C, then the trapezoid ABCD is an isosceles trapezoid. Alright, and then for the last one, isosceles trapezoid diagonal theorem is a trapezoid is isosceles if and only if its diagonals are congruent. So trapezoid ABCD is isosceles if and only if AC and BD are congruent. So if they tell you that these two segments, AC and BC, are congruent, then it's going to be an isosceles trapezoid because they have to be at the same angle and the same separation. So if you got those segments that are congruent, you will be able to tell that it is a isosceles trapezoid. The key word is if and only if. They don't tell you those segments are congruent, we cannot assume that it's that is an isosceles trapezoid. Now these are different theorems. If you already are able to prove that the isosceles trapezoid is an isosceles trapezoid, then all of these theorems apply. You can use them to prove that this is an isosceles trapezoid. So we have the mid-segment of a trapezoid. It's a segment whose endpoints are the midpoints of the legs. So what does that mean? This line right here, the mid-segment, it's cutting this trapezoid perfectly in half when it comes to height, okay? If you cut it perfectly in half, that means this section and this section are going to be congruent. Obviously within the same segment. Because this is not an isosceles trapezoid, this whole segment is going to be a different length from this whole segment. So you have to remember and notice how they use different tick marks to mark the segments. but it is the same rule. It breaks it exactly at the middle. So we have theorem 7.17, trapezoid mid-segment theorem. This states that the mid-segment of a trapezoid is parallel to each base and its length is 1/2 the sum of the length of the bases. So here they're telling us XY is parallel to BC, which is parallel to AD. So all of these are parallel to each other. Now, they're telling you, this is where the transitive property comes in. XY is parallel to BC, and XY is parallel to AD. So BC is also going to be parallel to AD. Now, how do you find the length of XY? Because they're parallel, you will use this formula. 1/2 the BC plus AD. Now, I don't particularly love the naming convention, so I'm just going to call this base 1 and this base 2. When I do that, you can either do base 1 plus base 2 over 2, or you can use that equation that they gave us, 1/2 and base 1 plus base 2. Now, it doesn't matter which one's base 1 and which one's base 2, because you end up adding them anyway. All right, now we have a kite. A kite is a quadrilateral with exactly 2 pairs of congruent consecutive sides. The key word is consecutive. So that means that these are consecutive to each other and these are consecutive to each other. So these are the properties of the kite. We have the theorem 7.118 and 7.19. So the theorem is, if a quadrilateral is a kite, then its diagonals are perpendicular. Their diagonals are these right here. Now if they're perpendicular, we can assume this is a 90-degree angle. So AC is perpendicular to BD. And also, if a quadrilateral is a kite, then exactly 1 pair of opposite angles are congruent. So these 2 angles are opposites of each other, they will be congruent. Now, it's always going to be angle B and angle C, so the ones in between both of the sides that are the short and the long side, but it's not going to be angle A or angle C. Keyword right here is exactly 1. So they want us to find angle A. Let's do this one together. So,
Together.
all right, so we know this is we have a trapezoid. That means 2 of the sides are parallel to each other, so this is the base and this is the base. And we have there our congruent sides. Now I'm just going to redraw it vertically. And when I do that, we know because this is an isosceles triangle, these 2 are going to be congruent. But we also know because this is a parallelogram, they have to add up to 180 because those are supplementary angles. So the way we find angle A is by doing 180 minus 100, and we get that is 80. So the measure of angle A is 80 degrees. All right, so to find angle F, we know again that this is an isosceles parallelogram, so these 2 angles are congruent. And we have to remember this is a parallelogram, so they are supplementary of each other. So we're going to do the same thing we did before. 180 minus 49 is going to give us 131. So angle F is going to be 131. Now there is another way you guys can figure this out. We know this is one way. Now, the other way you can figure this out, if you forget that they're supplementary, we know the sum of all of these interior angles are 360. And we know these 2 are congruent. So if we do, for example, 49 plus 49, we're going to get 98. And once we get 98, we can subtract it from 360. It's going to give us 262. After that, we can do 262 divided by 2, and we end up with 131 anyway. So if you forget by any chance that they're supplementary, because this is also a parallelogram, then you can just do it this way, the green way. We know the sum of the interior angles. Let me write that in. Is 360, so we can add the ones that we know are the same, subtract it from 360, and then divide it by 2. All right, so here they want us to find FB. So FB is this small section right here. And they're telling us KB is 21.9. MF, which is this whole thing, is 32.7. So how do we figure it out? We remember that the diagonals are congruent, right, to each other. The whole diagonal right here is congruent to this entire other diagonal. So because they are congruent, I can actually just go ahead and do 32.7 minus 21.9. And I'm left with 10.8. So FB would be 10.8. All right, so let's go over this. We have that in kite ABCD, we have the measure of angle DAB. So this entire angle is 54. Remember, that angle and this angle are, not those angles. B and D are congruent. And they're telling us CDF is 52. So this one's 52. So that means this one's also 52. And we want to find the measure of angle BCD. So that we want to find this angle right here. The whole angle. Now, we can do that a few different ways. We know that these two angles are congruent, angle B and angle D. So, and we know that this is 90 degrees. I'm just writing information that we might need for the triangles, right? So there's a few ways you can do it. The first way, you could do 52 plus 52 equals 104 and subtract it from 180 to get 76. Why do we do it that way? Because if you do it that way, we solve for this entire big triangle, right? So, and since you're solving for the entire angle BCD, we can do it that way and we can figure out that BCD is 76 degrees. Now you can also do it another way, which you can do 52 plus 90. Remember that we can do that because the diagonals of the kite are perfectly perpendicular. So we get 142. We subtract that from 180 and we get 38. Now that 38 is only half of the angle, this part right here, for example. So we would do after 38 times times 2. Wow, sorry, my pencil been messing up. We get 76. If you don't want to multiply, you can do 38 plus 38, and you still get 76. Those are two ways that you can get the same angle. So the 38 I got by solving for this small triangle. So I got 52 plus 90 and subtracted that from 180 to get this remainder angle right here. And now for this last example, Lucy is framing a kite with wooden dowels, and she uses 2 dowels to measure 18 centimeters and 1 dowel that measures 30 centimeters. 2 dowels that measure 27 centimeters to complete the kite, and then she needs a dowel to place along KL. She has a dowel that is 36 centimeters long. About how much wood will she have left after cutting the last 2 dowels? Now, that is a lot of information, but that's okay. We're talking about KL, so it's going to be this whole thing. But we don't know how much she has left over. So how are we going to do that? What's left over is going to be this little section right here. So we know this is going to be 15 and 15 because we cut this 30 centimeters perfectly in half. Honestly, since I know this is a kite and this is 90-degree angles, I'm just going to use the Pythagorean theorem to say a square plus 15 square equals 18 square. So then we get a square plus 225 equals 324. I'm going to subtract that number over, and I'm going to get a square is equal 299, and then I'm going to take the square root, and I get a to be the square root of 99. Now, I'm not going to simplify it right now. because that just seems like a lot and I really don't want to do it. But you do need to keep going. You also need to find the distance for this. And you do it the same way. I'm going to add a slide for this. The same way using the same formula. So a square plus 15 square equals 27 square. So we're going to get a square plus 225 equals 729. I will subtract the 225 from both sides. And I get a square to be 504.
Are you recording this?
I take the square root and I get a is equal to 22.4. Now, that is after I take the square root. I simplified the first square root of root 99 to be about 9.9. So to get the difference, you're going to actually do 22.4 minus 9.9, and we're going to get 32.3. And we're going to subtract that from the original amount of 36. So we're left with 3.7 centimeters of left over. You do have homework.